Hello guys, welcome to my channel VGR Solutions. I hope you guys liked my previous video. Today we're gonna discuss about terminating and non-terminating number. First of all, what is terminating number? The number whose decimal expansion terminates or ends after some but finite number of steps. For example, 7 by 8, 2 by 5, etc. In short, when we solve any p by q form number by division and its decimal expansion terminates, are terminating numbers, and which doesn't terminate or repeat itself after some steps are known as non-terminating number. For example, 10 by 3, 1 by 7 and so on. Now moving towards exercise 1.3 of Ncert book of 9th class. Our first question is, write the following in decimal form and what kind of decimal expansion each has. First one is 36 by 100. Now we divide 36 by 100 and it terminates after some steps. 36 by 100 decimal expansion comes out to be 0.36, which is terminating number. Now the second one is 1 by 11. Now by dividing 1 by 11, it comes out to be 0.0909 and continues like that. It never stops, so it is non-terminating and repeating number. Now the third one is 1 by 8. By simplifying it first, it comes out to be 33 by 8. Now dividing 33 by 8 and it comes out 4.125. We get a terminating number. Now next one is 3 by 13, dividing 3 by 13, and after a few number of steps it has a remainder 3 again. Now we have to repeat all previous steps. So 3 by 13 comes out to be a non-terminating and repeating number, which is 0.230769 and so on. Now the fifth one is 2 by 11. Dividing 2 by 11, we get a non-terminating number, which is 0.1818 and so on, as it gets a remainder 2 again and again and keeps on repeating. So by dividing 2 by 11, we get a non-terminating and repeating number, which is 0.1818 and so on. Now sixth part is 329 by 400. By dividing 329 by 400, we get 0 as a remainder after few steps, and the number comes out to be terminating, which is 0.8225. Now moving forward to second question. It says we have 1 by 7 equals to 0.142857. Can we predict what the decimal expansions of 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7 are without actually doing the long division? If so, how? Now, as we know, 1 by 7 equals to 0.142857 bar. Now for 2 by 7, we multiply the value of 1 by 7 by 2, and for 3 by 7, we multiply it by 3, and so on. This is the way to find decimal expansions of 2 by 7, 3 by 7, 4 by 7, 5 by 7 and 6 by 7 without doing the long division method. Now moving forward to next question. We have expressed the following in the form of p by q, where p and q are integers and q not equals to 0. The first one is 0.6 bar. To solve it, firstly we write 0.6 bar as 0.6666. Now let x equals to 0.6666. Multiplying the above by 10, we get 10x equals to 6.6666. We can write it as 10x equals to 6 plus x, where x is 0.6666. Now 10x minus x equals to 6, which is equals to 9x equals to 6, and which gave us x equals to 6 by 9, which further equals to 2 by 3. Now the next part is 0.47 bar, and simplifying it first, we get 0.47 bar equals to 0.4777. We can write it as 4 by 10 plus 0.777 by 10. Now let x equals to 0.7777, and multiplying it by 10, we get 10x equals to 7.7777. Now we can write 10x as sum of 7 and x, where x equals to 0.7777. Now 10x minus x comes out to be 7, and it gives 9x equals to 7, and further x equals to 7 by 9. Now putting x in the above equation, where we expanded the 0.4777, we get 4 by 10 plus 0.777 by 10 equals to 4 by 10 plus 7 by 90. Now multiplying and divide 4 by 10 by 9, we get 36 by 90, and our expansion becomes 36 by 90 plus 7 by 90, which equals to 43 by 90, which is the final answer. Our next part is 0.001 bar. To solve it, firstly we simplify it as earlier. 0.001 bar equals to 0.001001 and so on. Now we let x equals to 0.001001. Here we have bar on 3 digits, so we multiply by 1000. Then 1000x equals to 1.001001 and so on. 1000x equals to 1 plus x, which equals to 1000x minus 1x equals to 1, which gave us 999x equals to 1, and further x becomes 1 upon 999. Now moving towards our next question. What can be the maximum number of digits in the repeating block of digits in the decimal expansion of 1 by 17? We have to perform division to check the answer. Now solving it by dividing 1 by 17, we get a long division until the remainder becomes 1 again. We get 1 by 17 as 0.05882 and so on up to 47. There we get 16 digits in repeating block of the decimal expansion of 1 by 17. Now next question of the exercise is write 3 numbers whose decimal expansions are non-terminating and non-recurring. As we all know, irrational numbers are non-terminating and non-recurring. The examples are root 3, root 26 and root 101. We all can check the values of these examples here. Now moving towards our next question, we have here is find 3 different irrational numbers between the rational numbers 5 by 7 and 9 by 11. We all know that irrational numbers are non-terminating and non-recurring. So the 3 irrational numbers between 5 by 7 and 9 by 11 are the non-terminating and non-recurring numbers between the values of 5 by 7, which is 0.714285 bar, and the value of 9 by 11, which is 0.81 bar. Here we have the numbers. Now our next question is classify the following numbers as rational or irrational according to their type. The first one is root 23. Now we have the value of root 23 as 4.7958 and so on. Since the number is non-terminating and non-recurring, so it is an irrational number. Now second part, we have root of 225. Now solving it, we get 15. Now we have it in the p by q form, which is 15 by 1. Since the number can be represented in the form of p by q, so it is a rational number. We have third part as 0.3796. Now we can see the number is terminating itself, so it is a rational number. Now we have fourth part, which is 7.478478. Here we can see it is a non-terminating but recurring, so it is a rational number. Here we have the last part of the exercise, ninth question, which is 1.101 001 0001 00001 and so on. Here we can see the number is non-terminating and non-repeating, which we can see here. So it is an irrational number. As we know, irrational numbers are non-terminating and non-repeating. Thank you all. I hope you like my video. Do like, share, comment and subscribe for more interesting videos like this. Thank you.